We're going to get started.
Are there, when does everyone ever actually pay attention?
From Friday.
Oh, Friday.
Yep, we didn't finish the notes on Friday, so we are finishing them. Well, we'll work on them today. We'll finish them tomorrow. 1.3. I will give you the assignment tonight, but officially I'll assign it tomorrow. Because out of all the assignment or the problem numbers, all but 2 of them will have done. So there's only 2 of them that we won't have done. So if you wanted to get a head start on it, you could. But
so like when we do finish the notes, the answers are in basically.
How to do them, yes.
Cool.
So the first thing we're looking at today is reflection in the X and Y axis. Now the general form for reflection across the X-axis, reflection in the X-axis, is negative f of x. This is what we'll use to reflect across the X-axis. For reflection in the Y-axis, across the Y-axis is f of negative x. Questions on this here?
No.
All right, guys. So let's look at the first example of this here. So we have the function here, f of x equals the absolute value of x plus 3 plus 1. We want to write a function g, so g of x, whose graph is a reflection in the x-axis of the graph. All right, guys. Let's focus. All right, guys. Whose reflection in the x-axis of the graph of f. Now, since we're reflecting in the x-axis across the x-axis, negative f of x. Negative f of x. Notes from Friday. Now, f of x, we're going to replace it with its function, because since we still have f of x here, we're going to replace it with our absolute value of
X plus
3 plus 1.
Does it have to be in parentheses?
So this one here, yes, because we have that negative that's going to be applied to it. So here, when we plug stuff in, we normally put parentheses around it. Now, if there's nothing in front of the parentheses, we ended up dropping them and it just goes away. But here, there's a negative in front of it. So that negative has to be applied to every term inside the parentheses. Now, specifically here, there are 2 terms. There's our absolute value term and the 1. So we multiply that negative by the absolute value. The negative is not going to go into the absolute value. So we multiply the absolute value by the negative. It's just going to become negative absolute value of x plus 3. And then we're going to multiply the 1 by the negative, which is going to give us negative 1. So we multiply something by an absolute value. It goes in front of it. We don't distribute it through the absolute value. So our negative times that absolute value is just negative absolute value. Questions on this here? We ready for the next step?
Awesome. Can I get more out of the next step?
Yep.
Cool. You guys get ready to write some more.
Because there is no like terms that we have. The 3 and negative 1 technically are both constant terms, but because the absolute value, we can't combine them through. Yeah, so it's really because x plus 3, the disk 3 away from whatever x is. Then we have to apply the negative and go from there. So that is it. Next, we want to write a function h whose graph is a reflection in the y-axis of the graph of f. Now same function as the top one, yes. So f of x is still going to be equal to the absolute value of, I think it's x plus 3 plus 1. Yep, x plus 3 plus 1. Now this time, since we're talking about a reflection in the y-axis, our general form is f of negative x. No. All right, guys. All right, guys, let's focus up here. Now, our function f of x is what we started with, but we replaced the x in f of x with negative x. So every x in our function is going to need to be replaced with negative x. So we'll still have the absolute value bar, but instead of x, we're going to have negative x plus 3 plus 1. Now, almost, we don't, is there anything in front of the parentheses with our negative x besides the absolute value bar? No. So we can get rid of the parentheses, which tells us our new function h of x is equal to negative x, the absolute value of negative x, plus 3 plus 1.
So why did you have to do a negative if those over there weren't negative?
So here, so the reason we have to do a negative here is because we're taking f of negative x. Mm-hmm. Because it's a reflection across the y-axis. Now we can look at this here, not those. Because we have x plus 3 plus 1. Now, our reflection across the y-axis was negative x plus 3 plus 1. Just clear all that up. So this here, we can see it is a reflection across the y-axis. So the one in red is our original. And when we reflect it across the y-axis, we do get the one in blue. Now, if we reflected it across the x-axis, as we had negative absolute value of x plus 3, and then it was minus 1. And we can see that it is reflected down. Questions on this here? All right. We're going to look at two more with these reflections and then move on. Here, let f of x equal the absolute value of x minus 5 minus 4. Write a function h of x whose graph is a reflection in the x-axis of the graph of f.
So his absolute value bar is negative x.
So I'm going to start here. But yes, we will get there. Because I always start with the general form. So reflection in the x-axis is our negative f of x. Now we can replace f of x with its function. Absolute value of x minus 5 minus 4. Now at this point we can distribute the negative, which would give us negative absolute value of x minus 5, but we'd also have to distribute the negative to the negative 4. And our negative and negative would make a positive. So our reflection across the x-axis would give us negative absolute value of x minus 5 plus 4. All right, guys.
Okay, you're not saying my name. I didn't do anything, dude. I'm not even in a circle. I don't know what's going on.
Let's look at the last one here with reflections. We want to write a function g whose graph is a reflection of the y-axis of the graph of f. So y-axis would be f of negative x. All right, guys. Now at this point here, we need to replace every x in the function f of x with negative x. So we still have the absolute value bar. But instead of x, we'd have negative x minus 5 minus 4. Now, since there's nothing in front of the parentheses, with our negative x, we can drop them, just giving us the absolute value of negative x minus 5 minus 4. And that's it. There's nothing between the absolute value bar and that parenthesis, so they're not needed. Questions on anything so far? Do we need to see another example of reflections? All right. The last type of transformation we're going to look at is horizontal stretch and shrink and vertical stretch or shrink. Now, the general form with vertical stretch and shrink is a times f of x. A times f of x, where a is the factor that we're stretching or shrinking the function by. Now, if it's a vertical stretch, we're going to use a times f of x. Now, if it's a vertical shrink, we're going to use a times f of x. Doesn't matter if it's stretch or shrink, we're still going to use the a times f of x. Now, for horizontal stretch or shrink, we are going to use f of a times x. But before we can plug that value of a in or use the value of a, we have to flip it. We have to flip the given value. And this is only for applying a horizontal stretch or shrink. You have to flip the value that's given for it.
That's disgusting. Give me a tissue.
Flip the given value. Why do we flip the given value?
Because this is dealing with horizontal stretch and shrink, and it's only with horizontal stretch and shrink that it's a horizontal stretch and shrink by a factor of 1 over a of the graph. And this is the funny thing with horizontal. It's kind of that flip. It's the opposite. And it's the only one we really have to apply this to. Because the other one that is the opposite is the translation left-right, because it's x minus h. But the minus in the formula takes care of that flip, that kind of opposite direction. Here, there is nothing being applied to a to correct that kind of flip, that opposite. So we have to do it ourselves. We have to make it be 1 over a. Or we just flip it. So if they told us it's a vertical or a horizontal stretch by a factor of 2, so the given value is 2, our a is actually 1/2. We have to flip it. If they told us it's a vertical or horizontal shrink of 3/7, our value of a would be 7/3. We're flipping it. And horizontal stretch shrink is the only one we really have to do something to the value of A. Because even with horizontal translation left and right, if it was left, it was -4, because they're F4. But when we plugged it in is when we got the change. We didn't actually have to do anything to it. This is the only one we actually have to apply a change to. Now, before we get to horizontal, we're going to look at vertical. Let f of x equal the absolute value of x minus 3 minus 5. We want to write a function h of x whose graph is a vertical stretch of the graph of f by a factor of 2. Now, since we're talking about a vertical stretch, we're going to use the general form for vertical stretch or shrink, which is a times f of x. Now, we need to figure out what our value of a is. Well, what would the value of a be? So what's it saying it's stretched by? Factor of 2. So our value of a is 2. So all right, guys, we can talk about that here in a little bit. So the first thing we want to do is plug in 2 for A. Then just like with our reflection across the x-axis, we're going to do the same similar step next. We're going to replace f of x with its function. So the absolute value of x minus 3 minus 5. And our next step is to distribute. Now the first thing we're going to do is multiply the 2 by the absolute value. We will not multiply it through it, but we'll have 2 times the absolute value of x minus 3. And 2 times our -5 would be -10.
I'm listening. You're not even looking at the board. I've been told that for years.
Questions on vertical stretch or shrink?
Why don't we go from -5 to -10?
So when we,
Never mind, I skipped
okay. Now when we distribute this 2, we need to make sure that we do not multiply by the x or -3. It's not going to distribute through that absolute value.
You don't exactly like you do.
So you just get rid of the parentheses.
Yep. And then multiply it by the absolute value, then also by the -5. Now, technically, we could actually multiply through. It's a part of the because the absolute value of a times b is equal to the absolute value of a times the absolute value of b, which is one of the formulas. But the absolute value of 2 would just be, so technically we could multiply the 2 in, but we can't multiply a negative in. But instead of trying to keep all that straight, it's just easier to just leave the 2 out front. And then we would multiply any other term there. Let's look at the next one. Let f of x be the absolute value of x minus 3 minus 5, so it's still the same function. But we want to write a function g of x, whose graph is a horizontal shrink by a factor of the graph of f by a factor of 1/3. Now, our horizontal stretch and shrink is f of a times x. Now the factor that they gave us for this here. All right, guys.
He's gonna walk over here.
All right, guys. So the factor that they gave us is 1/3, but since it's horizontal, we can't plug it in. A is not going to be 1/3. We have to flip it. So 3 over 1 or 3, because 3 over 1 is the same as 3. So the factor that we plug in, the number that we're going to plug in for A, is going to be 3. Questions on this here so far? Now our next step is going to be similar to what we did for reflection across the y-axis in our horizontal translation. Because if we look at this here, we don't have f of x anymore. We have f of 3x. So we replace this x here with 3x, which means this x here also has to be replaced with 3x. So we'd have the absolute value bar. And then, instead of x, we have 3x minus 3 minus 5. Since there's nothing in front of our parentheses, we can drop them, giving us the absolute value of 3x minus 3 minus 5. And that's it.
That's how math works.
Questions on this here? We ready to look at another one? Let f of x equal the absolute value of x minus 1 plus 2. Write a function g of x whose graph is a horizontal stretch of the graph of f by a factor of 5. So horizontal stretch or shrink? Yes. We have this here. Now again, since we're talking about horizontal, we have to flip the number that they gave us. Now since they told us that the value was 5, we have to flip it to 1/5. And our next step is to replace A with 1/5. Let's see what I wanted. One-fifth x. And we get this here. Now again, just like the last one, we're going to replace every x in f of x with 1/5 x. We'd still have the minus 1 plus 2. Then we drop the parentheses. And that's it. Questions on this here? So the biggest thing with horizontal stretch and shrink is just remembering to flip A. Once we do that, we just plug it in for A and do the same thing we've been doing. We're ready for another one. Yep. So we have our function h. We want to write a function h whose graph is a vertical shrink of the graph of f by a factor of 0.25. Now for us here, our value of a is what? Nope. So, well, it's not going to be flipped because vertical. No, you're good. Because if it was horizontal, yes, we would flip it because 0.25 is indeed 1/4. So we'd flip it and it'd become 4. But because it's vertical, we don't have to flip it. So our h of x is equal to 0.25 times our f of x. And again, just like with the last vertical stretch or shrink that we did, at this point we just need to replace it with its function, x minus 1 plus 2.
Since there's something outside.
We have to distribute it through. Now our 0.25 times our absolute value, well, it will be 0.25 times the absolute value of x minus 1. Now we also need to do 0.25 times 2. And 0.25 times 2 would be plus 0.5. And that's it. Questions on this here?
I thought this class would be fun.
Say that.
No, I thought it was gonna be
Jonathan,
like
shut up.
weekly or like every problem of your life.
Whenever that happens, it's your fault.
No, you can be smarter than that.
Now a lot of the problems,
No.
the more complicated ones, is just more steps. As long as we keep track of this and do this one step at a time, we're good with this here. Yeah. Questions on any of this here?
More steps is harder to keep track.
Yep. Do we need to see another example of vertical stretch and shrink or horizontal stretch and shrink?
Sure, let's do it.
Okay.
No.
Let's look at this one here.
More.
Because I think we only have 2 more anyways.
Okay.
So here we want to write a graph g write a function g whose graph represents the indicated transformation of, so g of x equals, so vertical shrink by a factor of 1/3. So our vertical shrink would be a times f of x. Well, what's our value for a?
1/3.
1/3. Since it's not horizontal, it'll stay 1/3. Now what's our function?
X.
Absolute value of x minus 3.
Absolute value of x minus 3. Now, up to this point, we have taken it one step at a time. We just rewrote 3 in times f of x, and then replace the function. Well, we could do that all at once. All right. Now we need to multiply through by 1/3. Now our 1/3 times the absolute value of x is going to be 1/3 absolute value of x. Now what's 1/3 times 3? 3/3, which gives us 1. And that's it.
Speak for yourself.
What she said. Oh my God.
All right, guys.
It wasn't me, I swear. I went in there. You, it was you.
let's look at this last one here, and then we'll be done for the day.
Last one, fold it in.
Radioactive on
All right, guys. Last problem of the day. Oh, this one's not on there. That's right. I just forgot to put it in there. So that's fine. So you guys can see this one here. So horizontal stretch by a factor of 2. Since it's horizontal, we have to flip it, and it's going to become 1/2. So we'd have f of 1/2 x. And our next step is just to replace every x in f of x with 1/2. So we'd have 4 times 1/2 x plus 2. Now our 4 times 1/2 would be 2. But that's it for today.